Application in war. Chemistry has also increased the striking power of man in war times. It is responsible for the discovery of highly explosive substances such as TNT, trinitrotoluene, nitroglycerin, and dynamite. Poisonous gases like mustard gas, levisite, and phosgene, and many other deadly weapons such as atom bomb and hydrogen bomb. Problems caused by progress in chemistry. The progress in chemistry has also caused many problems. For example, nuclear energy is useful, but disposal of nuclear waste poses a serious problem to humanity. Phonograph records have added to our pleasure for listening music, but they are made of polyvinyl chloride produced from vinyl chloride, which can cause liver cancer in industrial workers. Antibiotics have eliminated infectious diseases, but their overuse is very harmful. Insecticides have increased the food supply, but they do a lot of harm to birds, fishes, and useful insects. Use of polythene bags is posing a serious threat to sewerage systems. Chemistry has given drugs like LSD, cocaine, brown sugar, etc., which are proving a curse to the society. Conclusion. In view of the above discussion, we conclude that though chemistry can be regarded as greatest benefactor of humanity, yet it can prove to be a blessing or a curse for humanity depends upon the uses to which it is put and how a relative balance is maintained between benefits and problems caused by progress in chemistry. Name the discoveries of chemistries which have helped mankind and the same discoveries have harmed the mankind and how. Discoveries of chemical fertilizers and insecticides. These have helped in the growth of crop, but they are slow poisons for the mankind. Discovery of nuclear energy. It has helped in the production of electricity in nuclear reactors, but in led to making of atom bomb for destruction. Next, what is matter? Everything that is around us and the presence of which can be felt with the help of any of our five senses, that is sight, touch, smell, hearing, taste, is called matter. In fact, this whole universe is made up of only two things, that is matter and energy. Experience has shown that all types of matter possess mass and occupy space. Hence, matter is defined as anything that occupies space, possesses mass, and the presence of which can be felt by any one or more of our five senses. The examples of matter are innumerable. A few of these include clothes, iron, gold, plastic, wood, water, milk, petrol, kerosene, oil, and air, etc. Classification of matter. There are two ways of classifying matter. First, physical classification. Second, chemical classification. Physical classification. Based on the physical state under ordinary conditions of temperature and pressure, matter is classified into the following three types: solids, liquids, and gases. They differ from each other in packing of their constituent particles, as shown in figure. In a solid, the constituent particles are very closely packed in the orderly fashion, and there is not much freedom of movement except vibratory motion. Hence, they possess a definite shape and definite volume. In a liquid, the particles are comparatively less close to each other, and therefore they can move around. Hence, they have a definite volume but no definite shape. In a gas, the particles are far apart and therefore have a much greater freedom of movement. Hence, they possess neither definite volume nor definite shape. Based on these characteristics, the three states of matter may be defined as follows. A substance is said to be solid if it possesses a definite volume and a definite shape. Example: sugar, iron, gold, wood, etc. A substance is said to be liquid if it possesses a definite volume but no definite shape. They take up the shape of the vessel in which they are put. Example: water, milk, oil, mercury, alcohol, etc. A substance is to be gaseous if it neither possesses a definite volume nor a definite shape. This is because they fill up the whole vessel in which they are put. Example: hydrogen, oxygen, carbon or dioxide, air, etc. The three states are interconvertible by changing the condition of the temperature and pressure: solid to liquid, liquid to gas, gas to liquid, liquid to solid. Solid, heat, solid, it converts into liquid. Then again heat, it converts into gas. Gas, cool the gas, then it converts into liquid. Liquid, you have to cool the liquid, it converts into solid. Difference between gas and vapor. Vapors represent a gaseous state of a substance which is liquid at room temperature. A substance which is in gaseous state at room temperature is called a gas. In the next.